Hi everyone, today we're going to learn about arithmetic series. If you remember, we have talked about the difference between series and sequences. We said that sequence is when you are listing the terms like 1, 2, 3, and so on. And series is when you add up the terms like 1 plus 2 plus 3 and so on. So today we're learning about arithmetic series. That means we are going to learn how to add up the terms of an arithmetic sequence. So arithmetic series is sum of arithmetic sequence terms. Let's say I give you this sequence, this arithmetic sequence, or basically arithmetic series, and ask you to add them all up. So it's 1 plus 2 plus 3 and so on to 100. So I ask you to add up all the numbers from 1 to 100. Basically, it will take a while for you to find some of all these without using your calculator. Even with using calculator, it will take a while. There's a story behind this. There was a famous mathematician whose name was Gauss. When he was 8 years old in elementary school, his math teacher asked all the students to add up all the numbers from 1 to 100. The teacher was thinking maybe this way kids are going to be busy for a while and I will be on my own for a few minutes. But surprisingly, Gauss came back after just 2 or 3 minutes with the right answer. Teacher was surprised, like, how did he do this? This is how he solved this problem. He wrote all the numbers from 1, 2, 3 to 50. And then in the bottom row, he started writing the numbers from 51 to 98, like all the numbers to 98, 99, and 100. Then he added each column here. So 1 plus 100 is 101. 2 plus 99 is 101. This is 101, and 50 plus 51 is again 101. Then he added all these terms. Basically here we have 5101. So instead of adding all these, he just multiplied 50 by 101, which is equal to 50, 50. So that's how he added all the terms from 1 to 100. This is actually the beginning of finding the formula for the sum of the first n terms of an arithmetic series. Basically what he did here was to add the first term, which is 1, and the last term, which is 100. So 1 plus 100 is 101, and then multiplied by the half of the number of the terms that he had here. From 1 to 100 is 100 terms, and half of that is 50. So multiplied half of the numbers by the first term plus the last term. So we can use that, apply that to find the formula for summation formula. So sum of arithmetic series terms is actually n over 2 times a1 plus an. This is the formula that you can use to find the sum of the first n terms of an arithmetic series. So when you have the first term and last term and the number of the terms, you can use this formula to find sum. But sometimes you don't have the last term. There is another formula that you can use in this case. Sn is equal to n over 2 times a1 plus n minus 1 times b. So whenever you don't have the last term, you can use this formula to find sum of the first n terms. So let's do some examples here. So here we have this arithmetic sequence 3 plus 8 plus 13 plus 18 and so on. The first thing that I'm going to do here is find the difference between the terms. 8 minus 3 is 5. 13 minus 8 is 5. This is 5. So this confirms that we have an arithmetic series here. So I can use one of these formulas, either of them work. But since I have the first term a1 and the last term an, so I can go ahead and use this formula. I just need to find the number of the terms. How many terms I have here? 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 terms. N is equal to 8. A1 is 3 and A8, the last one, is 38. So I'm going to use this formula. S of 8, S8 is equal to n over 2, which is 8 over 2, times a1, which is 3, plus a8, 38. So this will be equal to 4 times 41, which is equal to 164. So let's do the next example. In this example, again, we have a series here. Let's find the common difference between them. 20 minus 8 is 12. 32 minus 20 is 12. The same for the other one. So I have an arithmetic series here. So I have the d value, which is 12. I have the first term, which is 8. And I know I have 10 terms. So n is equal to 10, but I don't have the last term. So I can go ahead and use the second formula here. Sn equal to n over 2 to a1 plus n minus 1 times d. So S10 equal to 10 over 2, 2 times 8 plus 10 minus 1, which is 9, times 12, which is equal to 620. Okay, so let's go to the next page. We already have learned about the sigma notation. We said whenever we have series, instead of listing all the terms like a1 plus a2 plus a3 plus all the way to an, instead of listing all the terms and adding them all up, we can use summation notation as a short way to write this series. So here, this is basically another form of this series. So when I say I equal to 1, here in the bottom side of sigma, this is the start point. And n is the end point. And ai is the sequence terms. And this I that you see here will start from 1, and each time we will add 1 to I until we reach to n. So let's do this example here. I have a summation here, I equal to 1 to 24, and the sequence term is 2i. So I can go ahead and expand this, but I don't need to expand all the 24 terms. I can do a few from the first and maybe 2 or just the last one of this series. So I'm going to start from I equal to 1 because it starts from 1. Then I will find the next one, I equal to 2, add 1 to I. Then I equal to 3, and then I'm not going to do all of them. I will do the last one, I equal to 24, and see what I will have here. Okay, so when I is 1, here the sequence term will be 2 times 1 plus 1. Then the next term, I, is 2. So this will be 2 times 2 plus 1. Then 2 times 3 plus 1. Then I will have 2 times 24 plus 1. So let's see what are the actual terms. So this is 3, this will be 5, this is, let me fix this, correct it. This is actually 2 times 3 plus 1, like this. So it will be 6 plus 1, 7, and the last one is 48 plus 1, which is 49. So these are the terms of my sequence. Now, I can find the difference between the terms to see what kind of sequence I have. 5 minus 3 is 2. 7 minus 5 is 2. So each time we are adding 2 to the terms to get the next one. That means we have an arithmetic sequence. So I can use the formula that I gave you here in the previous page. I can use one of these. So if I have the last term, I can use the first one. If I don't, I can use the second one. And as you see here, we already have the first term, which is A1, and also the last one, which is A24. We have first and last term, and we know that we have 24 terms. How do I find the number of the terms? To find the number of the terms, you can use this. Find the upper limit, which is 24, minus the lower limit, and then add 1 to that. We're adding this 1 because if we don't, then we are not counting the first term. So we're adding 1 to actually count the first one. So 24 minus 1 plus 1 is 24. That's the number of the terms. We have 24 terms here. So I can easily use the formula Sn equal to n over 2 a1 plus an. So S24 is 24 over 2 times a1, which is 3, plus 49. And if you use your calculator, you will see that this is equal to 624. So that's the answer of this summation. Now let's do this example. Again, I have a summation which is used with actually shown with sigma notation. So I'm going to expand this a little bit. Not all the terms, but maybe the first 3 and the last one. So I'm going to start with I equal to 5 because here I starts with 5. I equal to 5. Then I will find I equal to 6, I equal to 7, and then the last one, which is I equal to 30. So I don't have to expand all the terms. When I is equal to 5, so the term will be 2 times 5 plus 1. Then 2 times 6 plus 1. Then 2 times 7 plus 1. And then the last one is 2 times 13 plus 1. So the terms will be 11 plus 13 plus 15, and the last one will be 27. So the difference between terms here again is 2. So each time we are adding 2 to the terms to get the next one. So D is 2. I have A1, which is 11. AN, the last term, which is 27. And I need to find N. How do I find N? The upper limit, which is 13, minus the lower limit, 5, plus 1. So 13 minus 5 plus 1 will be equal to 9. Now I can use the same formula again. Sn equal to basically S9. We're using this formula actually. S9 is equal to 9 over 2 times A1, which is 11, plus AN, which is 27, and it's equal to 171. So that's the answer of this. Okay, now let's read this word problem. A ceramic tile floor is designed in the shape of the trapezoid, 20 feet wide at the base. So this side is 20 feet. And 10 feet wide at the top. So the top side is 10. The tiles are 12 inches by 12 inches. We know that 1 feet is equal to 12 inch. So if I have tiles that are 12 inches by 12 inches here, and I have 20 feet here and 10 feet here, that means basically I have 20 tiles in the bottom and 10 tiles on the top side of this trapezoid. Now, says the tiles are to be placed so that each successive row contains one less tile than the preceding row. So if the first one has 20 tiles, the next one is going to have one less than this one, so it's 19. The next one is 18, and so on until we reach to the top side, which is 10. Now it's asking how many tiles are required. So basically we have a sequence here: 20, 19, 18, 17, and so on to 10. So what kind of sequence I have? 19 minus 20 is -1. 18 minus 19 is -1. This is -1. So each time I'm subtracting 1 from each term to get to the next one. So I have an arithmetic sequence. Arithmetic sequence here. Now, how many tiles are required? That means you need to find the total number of the tiles. So we need to find the sum of this sequence. Okay, so in this sequence, I have A1, which is 20. I have the last term, AN, which is 10. And I need to find the number of the terms. How many terms I have? You can subtract 20 minus 10 and then add 1. So I have 10 terms here. Oh, I'm sorry. It's 11. So we have 11 terms here because 20 minus 10 is 10 plus 1 is 11. Now I can use the formula Sn equal to n over 2 A1 plus AN. 11 over 2, 20 plus 10, which is equal to 165. So we need 165 tiles to put ceramic tiles here in this trapezoid formed floor. So this was today's lesson. Hopefully it was helpful for you. Have a great day.